All right, so I know most of my students are in the underground mining class that I'm teaching this semester as well. So I'm not going to go into quite as much detail as I did in that lecture, but suffice to say that this past week has been pretty tragic for state of West Virginia and the greater coal mining community. This past Thursday, there was a fatality and a second injury at the Matiki mine in Tucker County, and that was followed Saturday by an inundation at the Rolling Thunder mine in Nicholas County, West Virginia, where I'm from. And there is an individual, one mine worker, who is still unaccounted for. Rescue operations are ongoing, pumping, drilling from the surface. They even have 3 scuba teams on site. So that's currently happening, as we speak. And because of that, I wanted to steer the direction of these 2 courses towards a safety-related topic. And to do that, we're going to discuss some of the surface mining fatalities that have occurred this year to date, in the United States, so in this country, in various commodities as well. So we're just going to basically jump into this. And year to date, there's been 18 surface mine fatalities, 3 coal, and 15 metal, non-metal. That's a little bit striking. First of all, you're seeing that if you've seen the underground presentation, you may not have, that, this is almost 4 times higher than the number of underground mining fatalities that we've had. So it's up there. 3 coal, 15 metal, non-metal. That is fairly striking, at least to me. It's been a while since I've looked at accident fatality trends, from my previous, work experience, but that seems pretty striking to me. Typically, especially in the underground side, you tend to have more fatalities in coal than you do metal, non-metal. But MSHA, the Mine Safety and Health Administration, if you go on their website, you can find a list of all the fatality reports. You can find other injury data as well. But for today, we're going to be looking at the fatality reports. And when you scroll down on this page, what you come to, you'll see listings of the fatalities, right? And the first fatality of this year, January 3rd, was falling, rolling, or sliding rock or material of any kind. So falling, rolling, or sliding. In this case, this is a sand and gravel mine, and basically the worker was replacing a 12-inch discharge line in this trench. The trench wall collapsed on him, crushed him. Best practices, as I mentioned in the other video. These best practices, like I said, are sort of canned responses, so they don't necessarily give a lot of detail as to how it's applied to what has occurred here, right? So just a list of best practices. I'm not saying they're not good best practices, but they may need adjusted for different applications. But in this case, stay clear of potential unstable areas. Yeah, great idea. Do not enter trenches if the walls are not properly supported for the full height or slope to a safe angle. So that's what you're missing here. There's no support in here. It's obviously pretty deep. I think this might be a hard hat. It could be the mine worker's hat. And so this pipe's 12 inches as well. So it's a pretty deep trench. Establish and discuss safe work procedures before beginning work. Identify and control all hazards associated with the work to be performed and the methods to protect persons. And it says to follow OSHA trenching and excavation safety guidelines. I think this might, I'm not saying it's never happened before, it probably has, but this is the first time I remember seeing, one agency sort of, throw it over to another here. But anyways, this occurred on January 3rd. On the 29th, there was a fatality at a coal surface mine at Twilight, Boone County, West Virginia. A miner died when a piece of rock fell from the high wall, struck the cab of the drill he was operating. Okay. So when you actually look at this high wall, what do you see? And the first thing I see is right here. There's clearly a bedding plane and a lithological a separation here, right? So that this rock is not the same as this rock. And given, the position of the drill, it looks to me like this could even be, overhanging a bit in here. So best practice is to scale high walls, right? So from a safe distance, from a safe location, right? So this, scaling eliminates loose hazards like unconsolidated rocks and overhangs, right? So you go in there and you're basically just, using a piece of equipment to sort of just scrape it, basically, it's not really scraping, but you're just breaking off that unconsolidated loose material. Conduct high wall examinations prior to working or traveling near the high wall more frequently as ground conditions warrant, especially after rain, freezing, or thawing. Yes, rain, freezing, and thawing have an impact on high wall stability. Okay, even if it's just raining, you'll see for yourself if you're ever in this situation. You're going to just see rock dripping off the high wall. And so to conduct an examination prior to working. Yeah. And more often as necessary. And to examine it from multiple perspectives. Bottom, side, and maybe even the top or the crest. A lot of times, it's not necessarily easy to access that, but that often, but an initial assessment, sure. To look for signs of cracking or other geologic features that could lead to instability. All right. In our ground control class that's coming up next semester, we'll be talking about this a lot. So, use auxiliary lighting during low light conditions to conduct examinations. So if it's dark, use lights. And ensure miners work, travel, and operate equipment at safe distances from the high wall. So when you are mining, you want to position yourself, your piece of equipment, as far away from the high wall as possible. Obviously, you have to get up there and mine the material. But you should be positioning yourself the best you can. Stay away from it. Number 3 is January 30th, another sand and gravel operation. In this case, a miner died when he became entangled in a log washer. The victim was starting the log washer when he lost his balance and fell into the log washer. Now, I'm going to tell you right now, I have no clue what a log washer even is. I don't know. I didn't Google it. This is obviously some sort of screening, conveying piece of equipment. I don't know what it is, but the best practices on this: 1, lock and tag out machinery against hazardous motion. They didn't throw in the tryout in this one, like they did in one of the underground ones. We'll see if it's in here anymore, but lockout, tag out, yeah. Fall protection is important, right? Let's put it this way. Think about it. There are people that have fallen over in their chair and died, okay? It's possible. The statistic that I usually quote is that half of all falls over 10 feet result in a fatality. So that, also training of miners and recognition of hazard and safe work procedures. You're going to see this more and more and more, I think, at least, where training and training requirements sort of are being updated and increased over time, right? So that's, I believe, from my perspective, the direction we're going, that we're going to be seeing more training, not less. The next was actually on the same day, I believe. Dimension Stone quarry, the surface mine, powered haulage. Okay, so in this time, a miner died when a front-end loader operator unknowingly lowered a pallet of stone onto him. So if you can imagine, you're sitting here in this cab, right? What happens when you pick up this load of stone, right? Visibility is decreased, right? But I have to ask myself, why was the person underneath the stone so that they could be crushed by it? And I don't know the answer to that. I'm not saying it's the victim's fault in any way. But what I am saying is that if you are around a suspended load, even if it's suspended hydraulically, you should not go underneath it. Some of the best practices from this, developing traffic rules for mobile equipment and miners on foot, collision warning technology, that could have helped. Adequate clearance and visibility. Like I said, I mean, this is as visible as it gets, right? I mean, you need to be known, what's in front of you and what's underneath you, but yeah, anyways, and training all persons to recognize the limited visibility and blind areas inherent to the operation of self-propelled mobile equipment. So we do get back to this training one more time. So yeah, you need to understand that all equipment, it doesn't have to be big equipment, okay? I mean, even my car has blind spots, right? So, it only gets worse the bigger the equipment is or the more confined the space is, right? So the next fatality, like in February, we were in coal, once again, surface mine up in Ohio. A miner died when the ground beneath the drilling rig he was operating failed, causing it to overturn and fall off the high wall. So this, the drill the operator was running was originally up here somewhere, and then the ground gave way and fell off the high wall. And when you're looking at this picture, what do you see? Well, I can tell you what I see. What I see is what looks like a very highly fractured ground to me. Right? I also see I don't know if this is coal right here, or it sure looks like it. If not, it's some kind of black rock, right? And you can clearly see that what's above that is very different than what's here, right? So I don't know specifically from this angle if there's an overhang. If there was an overhang, I can see that this is sloped a little bit, but again, examining high walls and correcting hazardous conditions before beginning work. Being aware of changes from freeze and thaw cycles. So again, we're still in the winter time, right? And it does affect high wall conditions. Operating drills perpendicular to the edge of the high wall. It looks like this one might have been parallel, but if it's perpendicular, then a portion of the machine is further back along the wall, right? So that you're in a relatively safer location. Monitoring activities, and then training operators to identifying hazardous high wall conditions, right? Which is, like I said, something we're working on. Better training for identifying hazardous conditions. And I think, the future, as I mentioned in the underground video, that the way we're going to be going is towards using VR or augmented reality to help sort of identify, right, these hazardous conditions. The next, powered haulage. Here we have, this is a cement plant facility. I also put facilities in here on the surface because they are on the surface. And in this case, the contractor died when the bridge providing access into the kiln shifted, and it caused the skid steer he was operating to fall backwards into the clinker chute. Okay. Providing safe access to all work areas. Following instructions for the bridges and ramps. Examining structures for indications of structural weaknesses. Now, that's something that I don't think we probably routinely do enough. But there is that in here. Training monitors and neuroscience tasks, how to identify, report, and correct a hazard. Once again, training in there, and then examining work areas beginning and throughout the day. The next, crushed broken granite. This is Martin Marietta out in North Carolina. And in this case, a miner died while clearing strips of old belt rubber from a belt conveyor tail roller. During this process, the conveyor started to operate, causing the miner to become entangled between the fluted tail roller and the belt, which would be absolutely terrible. But in this case, this belt was locked out, but it turns out that this belt was not. And so it needs de-energized, locked out, tagged out and block belt conveyors against hazardous motion before performing repairs. You'll notice it says block conveyors. You do need to block them against motion. Similarly to how you would block a vehicle or a truck bed or an in-loader bucket, against motion, right? Remember how I said you would not want to be, underneath something that's even hydraulically supported. The same goes for belts and that sort of thing. So they need to be blocked. And installing adequate guarding to prevent contact. I'm sure since the person was working on the belt, that guarding had probably been removed. It looks like the others are guarded. Train miners on safe work practices. So training miners on this procedure again. So moving on. This one is explosives and braking agents at a crushed broken limestone. So limestone mine in Illinois, Jersey, Illinois, which is a little bit confusing, but it's Illinois. Here a miner was fatally injured at a surface mine when fly rock from blasting operation struck him. The miner was assisting in detonating the explosives. So they were down over the lower bench, over the high wall. There was a battery box on the front end loader that was used to fire fly rock. So some best practices for this situation to remove all persons from the area, unless using a suitable, blasting shelter, right, to protect from fly rock. You need to wait at least 15 seconds for any fly rock to drop and settle before exiting the shelter. What this person was probably doing, is my guess is hiding up under here. But I'm not certain of that. I'm just making that assumption based off of certain things I've seen before. Adjust the stemming depth and or decking material to maintain adequate burden on all sections of the blast hole. So we've talked about burden and spacing and stemming, so that needs to be considered, along with geology, phase geometry, and topography. Determine the actual burden for all face holes along their length and adjust the explosive powder factor along the borehole accordingly. And to use approved capacitor discharge or generator blasting machines. So, yeah. shouldn't be using the battery box of the inverter. The next, powered haulage at another sand and gravel mine in Kansas. Miner was fatally injured at a surface mine when sand from a high wall engulfed the front end loader he was operating. The miner was digging sand from the tow. Okay, so the end loader, it's sand. So use mining methods that ensure stability and safe working conditions. Okay. Use appropriate equipment to gradually flatten the slope, starting at the top of the hot wall. Okay, so you can tell he's loading it from the bottom, and there's things start from the top. Equip front end loaders with two-way communication systems, high-strength glass, and SCSR for breathable air. Basically making what we call a scuba setup, for like you would on a dozer. So if your mobile equipment does get engulfed, you have your odds of survival is much higher. Yeah, that would make sense, probably for sand and that sort of thing. Because it's not really that much different than a stockpile, right? Examine high wall spoil banks and ground that slope into working areas. Correct unsafe conditions. Conduct additional examinations as conditions warrant. And then finally, look at train miners to assess risk and hazards, and correct or barricade hazards to prevent access before beginning work activities. So, again, back to the training and training miners to, like I said, to assess risk and hazards. So, something that we're going to be working on more in the future. Better training practices. Next up, falling, rolling, or sliding material of any kind. Okay, so once again, this is a tailing cell. In coal, we would most likely know these as a slurry cell, for example. So when you're storing, coal waste slurry, you have to put it somewhere. A lot of times it's behind an impoundment. Sometimes it's slurry injection into an underground mine. But you can also make slurry cells on the surface, and it's basically just a rectangular pond that has, linings in it, like midnight clay or something like that, clay material that you then fill with this waste material, right? And so the material from the tailings cell engulfed the excavator he was operating. So that means, again, that, this is almost like, this is sliding material. This is, if you're familiar with coal stockpiles, this is similar to running a dozer on one. At the time of the accident, the excavator operator was loading dry material into 2 haul trucks. So, establish and follow ground control procedures consistent with prudent engineering design for the safe control of all high walls, pits, spoil banks, in any area where might be working below a tailings or water storage cell. Okay, so you have to establish and follow ground control procedures. Examine high walls, banks, and other areas that slope into working areas, especially after rain, freeze, or thaw. So this is the same, best practice for that was in the previous, right? Because a similar condition has occurred. And equip excavators to communication systems. That's given a scuba setup and staying clear of unstable areas. Next up, we have another sand and gravel machinery fatality on June 15th. Miner died when the telehandler he was operating overturned onto him while he was outside the equipment moving a water pump suction line. So he was actually off the equipment. It overturned, as basically in the condition you see here. Best practices ensure miner operators operate telehandlers perpendicular to the slope So again, allows more of the equipment to be further away, so that maybe this won't happen. It's also in this case, because you either want to be further away from the high wall, so perpendicular to the high wall, or in this case perpendicular to the slope. Parallel to the slope, perpendicular to the slope. Perpendicular to the slope. That way it's less likely to roll over, and that you should also use ground stabilizing devices, which I don't know if those were used or not, but it doesn't appear to be. But anyways, keeping them low to the ground unless the surface is level, because the further away you get, the more torque you get, right? So more likely to tip over. Don't like to see the load radius. Yeah, definitely not. Don't work alone unless you can communicate with others and they can see you. Ensuring miners position themselves in a safe manner while working around equipment. So make sure you're in a safe place. Conduct inspections of mobile equipment prior to use, and if there's deficiencies, they need to be corrected. So, do all of these necessarily apply to this? I'm not sure, but these are best practices associated with telehandler slopes. Like I said, you can see the overlap, right? You can see the overlap in a lot of these things. Next up, we have powered haulage, which was at a cement plant in Colorado. Delivery truck driver died when the truck he was driving traveled off the road, crashed into a ravine. This is a delivery truck, and went off the road, whatever the hell. In this case, I think the second one is probably one of the bigger things here. Ensure berms and guardrails are at least as high as the mid-axle height of the largest mobile equipment using the roadway. That is a requirement for any road, and we'll talk about this a little bit more as we go, but berms are very important, or guardrails, but generally speaking on surface mines, you're going to be talking about berms, and they're very important, to stop things like this from happening. Okay. And the requirement is that it has to be at least mid-axle height of the largest equipment using the roadway. So, for example, a big 320-ton truck with a 12-foot diameter tire, you're going to need a 6-foot berm, right? And so the idea is that if the truck does run away, does try to go off the road, the berm will stop it. And generally speaking, when they're constructed well, they do. Always wear a seatbelt. I don't know if that's in here because the operator was not, but you should wear a seatbelt. Ensuring the braking systems stop to hold the equipment with a typical load. Pre-op inspections of equipment. And then, of course, maintaining a control of equipment and following posted speed limits. Next up, we have a machinery classified accident from a dimensioned granite quarry in California. And in this case, a contractor died when the excavator he was tramming, so he's just tramming, toppled forward, causing the cab to land on a boulder. And so we see he's kind of positioned so I guess he's tramming. I assume that the machine hasn't rotated, after it went over the embankment. So maintain the boom in the direction of travel when tramming. And that's typically what you would do. So it looks like in this case that was not occurring. Maintain control of self-propelled mobile equipment. Lots of motion. That was the same, right? It's worded a bit differently, but it's basically the same from the truck. Mature miners operate excavators perpendicular to the slope. So once again, perpendicular to the slope or high wall, whatever. And then training miners in safe operations and potential hazards of equipment, including avoiding ground conditions that can cause the equipment to tip over. Then, of course, workplace examinations prior to beginning work, and it doesn't say it in this case, but when necessary, as conditions warrant. Next up, powered haulage again, another standing gravel mine, and in this case, a contractor died after the front end loader he was operating traveled over the edge of a high wall, falling approximately 70 feet. So, end loader went over the high wall. I don't really know why, but I can tell you a couple of things to see from here. One, I see excess material in this area, and I'm not for sure why, but it probably came from here, right? So I don't know if the end loader, where it was exactly, but it looks like it was further away than that, but I do see that occurring here. The other thing that I see is, this deposit is, it's sand and gravel, right? There, so it looks like it's dipping to me. It looks like it's, very weathered and not weathered, but fractured and broken. So that's what I see when I look at this high wall. But best practices maintain control of self-propelled mobile equipment while it's in motion. We've heard that before. Never attempt to enter or exit an out-of-control vehicle. Usually we think of exiting, jumping out. Don't do that. Statistically speaking, you're far more likely to survive if you stay in the vehicle. Ensure miners are adequately task trained. Maybe that was an issue in this case, not sure. But it is mentioned here. Performing regular pre-op examinations of mobile equipment. Monitor work activities, ensure both miners and contractors follow safe work procedures. Next up, powered haulage again. Surface, limestone. And a miner died after the haul truck he was driving went over a berm along the haul road, over a high wall, and overturned into water in the pit. And that is, about as worse an outcome as I could think would be possible. But again, back to berms. Berms need to be at least mid-axle height. They need to be well constructed. If it's soft material, a truck might just go right through it. They need to be well constructed to ensure that an out-of-control vehicle won't go over the hill, or over the hillside, or down into the pit, or whatever. But again, always operate the equipment to safe speed, and following the safety surface mobile equipment safety program at your mine. Marking hazards on roadways with signs or signals. Always wearing a seatbelt, never attempting to jump out. Basically, a list of the same thing over again from the previous, basically 2 fatalities, right? So we've got about 3 in a row that are trucks or equipment, that's gone over a wall. Next up, we have a hoisting accident that occurred and caused a fatality at Marfork here in Raleigh County in West Virginia. August 26th, electrician died while performing elevator testing. This is terribly tragic. And the elevator car descended and struck the electrician who was on the first floor of the platform. Best practices: lockout, tag out, blocking out machinery against hazardous motion, including unintended movement. Right? Audible and visual alarms to warn of impending movement. Not saying that they didn't have those, but assuring the alarms are functional through testing and maintenance. It's sounding like they may not have been. I don't know, but like I said, you can't necessarily guarantee that based on the best practices in this list. Staying clear of moving equipment during testing and training miners to safely perform testing procedures and ensure that they're followed. So that, once again, is a facility, right? This is a surface area of an underground mine, but I've included it in the surface for the purposes of this class. Next up, we have powered haulage again. Surface sand and gravel mine in Rhode Island. A contract haul truck driver was injured while dumping loaded material atop the stockpile. So the bear dumped the loaded material. The ground under the truck failed, causing the truck to overturn onto its cab. The driver died later from his injuries. So best practices, constructing substantial berms. I like that, substantial berms. That's what I've been saying all along. You know, you have to make sure your berms are sufficient, you know. Bumper blocks even, or safety hooks. There is some sort of impeding device at a dumping location. Conducting workplace and ground conditions examinations before beginning work and as necessary. They're not listed in this one. Always dump material from a stable, safe location. If examinations indicate that the ground's not good enough, dump it back and then push the material over the edge with a dozer. Okay. Never load material from the toe of stockpile that is below an active dump point. Typically, it's a slope that's unstable or too steep, so once it gets beyond the angle of repose, it can slide. Maintaining stockpile slopes no steeper than the angle of repose. Guess I just said that. Okay. So that brings us to our most recent fatality, and in this case, this was at a surface limestone mine. The preliminary report is out on that. There is no final report or fatalogram associated with that yet. So it's not out yet, but this fatality did occur. And so with that, I want to leave you with some parting advice, and that is that you're likely to go through fatalities like this, whatever happened over the course of that previous year, in your, say, 8-hour annual refresher courses or something like that. This is very common. This is a good practice for you regardless, is to every once in a while, I guess annually basically, keep up with the trends in injuries and fatalities in the industry, so that you can be better aware of, what's going on currently across the country, what's going on, in your commodity or in others, to see sort of, trends, and you can use that to, help inform, what you're doing on a safety and training sort of basis at your mine, right? So with that, we'll see you next time.